Hello everybody. We're going to look at the logical operators again, and this is the second video that I'm introducing these. And the examples that I'm going to use this time are going to be taken from the textbook Python for Biologists that we're using this semester. So let's go ahead and put those in here and go through them. To begin with, let's just look at what we have on the screen already. And we're going to start with the AND logical operator again. And I'm going to go through and print out the examples, the names of the examples to the output window as we go through this. So we're going to use this same list that you've seen before that we took out of the book, or the authors used in the book. And we're going to now implement some if statements involving the AND logical operator. So let's start with a simple one here. So in this case, we are just going to have the simple for loop. Okay, so we're going to go through the list for accessioned in ACCS, so that just means we're going to extract one item at a time from left to right through the list. And then we're just going to do a little query concerning what we pick up. And we're going to check to see if the particular accession that we pull from the list, we'll see if it starts with an A, and this is where the logical operator comes in, and we're going to see if it ends with the 3. So the logical operator allows us to do this. So we can give it a condition here, followed by another condition on this side. And if we get both of those to be true, then we'll print out the accession. So this is going to filter out the accessions in the list that start with an A and end with a 3. So now this is a very simple program to begin with, so we're just going to go ahead and run it and demonstrate that this part does work. So we'll go ahead and run our program. When I bring over the output window, then we can see the results. So let's bring that over here. So which one of these accessions begin with an A and end with a 3? Well, if you look through the list, you'll find there are a few that begin with an A, so that would satisfy the first part, the first test, if accession starts with an A. So we have 3 that would make that part true with the AB56, AY93, AP97. But in order for this entire if statement to be true, then we have to have the accession terminate with the number 3. And there's only one that does that. So even though we have this first one starts with an A, then it doesn't terminate with the 6. Therefore, it ends with a 6, and that means that this right side of the AND operation is going to be false. So we need both of those to be true, the left side and the right side to be true, in order for the whole thing to be true. And the only one that satisfies that condition is AY93. It starts with an A and it ends with a 3, so that's the one that we print out. Now let's proceed and let's look at some other examples. This time let's take a look at the OR logical operator. So this is going to be example number 2, and we're still going to be using that same accession list. So I'll copy and I'll paste it here, and I'm going to go ahead and include it. Once you've done this definition once, you do not need to repeat it. But since I want to have it close by the if statement that I'm examining, I'll just go ahead and put it in here. And it doesn't hurt to reset the list as we are doing here. Now, this one says the for loop is still the same for accession in the ACCS, so we'll go through the list. Then the if statement states if it starts with an A or if it starts with a B, then we'll print it out. So notice here the OR logical operator, and that's the whole point. We want to look at the OR and the AND. In the case of OR, if we have the left side true, then the whole thing will be true. And if we have the right side that's true, the whole thing will be true. Both of these can be true, okay? Then the whole thing would be true. So the only way that the expression including an OR logical operator, the only way that can be false is if both of the expressions on the left and the right are also false. In the case of the AND, the only way that that can be true is if you have both sides being true. With the OR, you have both sides false, the whole thing is false. Otherwise, it's going to be true. So if it starts with an A or if it starts with a B, then we'll print out what that accession is. So let's run this example. So I'll run it. We'll bring up our output window and we'll just bring it over so we can see what the output looks like. And you can see that in example number 2, if it, let's see if I can move it away so we can see the if statement. I think I can. Okay. So you can tell that if it starts with an A, then we print it out. So we have AB56, AY93, AP97. Or if it starts with a B, that makes the expression true, we print out BH84, BD72. So the only one that we do not print out turns out to be the one that starts with an H. Okay, we didn't check for an H. So when we had the starts with A, then H is not equal to an A, so that side would be false. Or if it starts with a B, well, HV76 does not start with a B. So in that case, the left side is false, the right side is false. So the OR statement is false, and we don't print out the value HV76. Now we can use as many of these ands and ors in an expression as we want. And we call those compound logical expressions. So let's look at an example of one of those. So I'm going to copy the example again, this example, and I'll paste it here in our code window. Hit enter, paste that in. And we have the same list as before. And this time the choice for the variable that goes through the loop is just ACC. So I guess maybe the author of the book decided he got tired of writing out accession, so we're just going to abbreviate that now with ACC, and it does make this whole thing shorter. But let's look at it. So here's the if statement. Now notice, first of all, the parentheses. So we're able to group these logical conditions with parentheses. And well, we didn't really need to do that up above because we were using the expressions or the method starts with and ends with, so we really didn't use the relational operators up there. So in this case, though, we do need to group them because we want to make sure they're evaluated in a certain order. So the first thing we have is the left side of this expression, which is an AND. The right side of the AND just says AND, it ends with the number 4. So here on the left-hand side, we have a compound logical expression. So let's look at it closely. So if the particular item from the list, if it starts with an A or if it starts with a B, then we want to take that one. Okay, if it starts with an A or if it starts with a B, either one. And that's what we just saw up above. If it starts with an A or if it starts with a B, then we print that out. And here, in this case, we've got the OR. So it will be true if it starts with an A or if it starts with a B. So that's done first. Okay, so we're going to test to make sure that this particular element from the list begins with an A or with a B. Then we're going to make sure that, well, we're not going to make sure, but we're going to test to see if it also ends with a 4. So how can this whole thing be true? Well, we know that with an AND, this side has to be true and this side over here has to be true. Within the parentheses with the OR statement, either one of those being true means the whole thing will be true. So what this does is we're going to pick out all of the elements from the list that begin with an A or a B and end in the number 4. So let's just look at them. So we have here is AB56, so that satisfies the first part. Okay, so the left-hand side here, that would be true for the first one. And for the second one, okay, B, that would be true. And also for the A and AP 93, 97, and the B. So that all of those 4 would satisfy this condition on the left and make that whole thing true. But on the right-hand side of the AND, we have to have the item ending in a 4. So there's only one that does that. Okay, so B is true for the first part of it, and it ends with a 4. That's also true. So that's the only one that ends with a 4. So that is the one that we will select from the list and print out. Okay, so now this is a compound expression. And it's important to use the parentheses to make sure that these are evaluated in the order that you want them to be. Okay, if you don't do that, then they're evaluated strictly left to right. So if we didn't have that parentheses there and that one over here, then we'd end up evaluating this one and then that one and then this one over here. So it would be unclear what we would actually get. Okay, anyway, pay attention to the parentheses. So now let's run the program, and this compound expression should only pick out the case BH84. So let's run the program to check and see if it does that. So I'll fire it up, and if I bring this over, then yay, look, we get BH84. So that's the only one that satisfies this kind of long logical expression that we have written here. But you can do that. Okay? So it starts to get more complicated, maybe harder to understand as you do it, but the language allows you to do this. So you can have as many ands and or combinations as you want. All right, now let's look at the other logical operator, which is the NOT operator. So let's paste in the preliminary stuff that we need. So this is going to be the negation logical operator called NOT. So this is example 4. We're still using the same list. Now let's look at the for loop and the if statement that we need in order to give an example of the NOT logical operator. So we'll put that here, and let's move it up on the screen a little bit. So we have the same for loop that we had up above. So for ACK and AX, then we have our if statement. So this, the for loop goes through each item in the list and pulls out the items, and then we'll examine them with the if statement. So if it starts with an A, and look at the NOT here, okay? We've got the AND operator followed by the NOT operator, all right? So if it starts with an A, and what this really means is it does not end in a 6, okay? Let's take away the NOT briefly here. If I take that out, then this means that if the item from the list starts with an A and it ends with a 6, then we want to make that true and print it out. We print out the ACC. So in this case, we would have AB56 would be printed out. But what we really want is we want to print out all of the items that begin with an A, but they do not end in 6. Okay, so that's what we want to do here. So we can negate this condition here by placing not in front of it. So we'll put the not back in. So that's what that means. If you have any condition at all, it can be the relational expressions, A greater than B, A equals B, num1 equals num2, all those things that I've shown you in previous videos. If you want to switch the true or false result from that, then you can use the NOT operator to do that. All right, so reading it one more time. If it starts with an A and it does not end in a 6, then we want to print this out. Now, in this case, we don't really have to use an extra set of parentheses, but if it makes it easier to understand, then we can put another set of parentheses there. So that clearly means that we're using NOT with the result of that test here. Then we're going to use the AND. All right, so this illustrates the NOT logical operator. Let's run the program and look at the output. And in this case, we have example 4, and sure enough, we see that we get an A at the beginning for each one of those, and we get a 3, we get a 7. So it does not print out the AB56, which ends in a 6. All right, so that's one way that you can do that. All right, so in general, anytime that you need to test the opposite of a true-false result, then you can switch it using NOT if you want to. The final thing we're going to look at here is that we can write functions that return either true or false. So let's look at an example of that. So let's paste in the preliminary stuff, writing Boolean functions. Okay, so Boolean functions are functions that return true or false. And as a side note, you might wonder, well, gee, that's a strange thing, bool, that's a weird word. And it's actually it's named after George Boole, who was an English mathematician, philosopher, and logician. So the computer science world has honored him by naming variables that end in true or false or produce true or false after him. So that's why we get the type Boolean. So you're welcome to look up George Boole if you'd like. Well, okay, where were we? How do you write a Boolean function? Well, it's any function that returns true or false. So let's take one of our convenient, familiar functions we've looked at several times, and let's use that as an example. So here is our AT content function that we wrote in earlier videos. So here is the slightly different name for it. We have a definition of the function, is AT rich, and it takes the input argument D and A. So this is the same code that we had before where we calculate the AT content. But notice that if the AT content is greater than 0.65, then it returns true. So it doesn't return AT content. It returns some true or false value based on how rich that AT content is. So when you have a return with a true or a false, then that means that we have a Boolean function. Well, this function doesn't do us any good until we call it. So let's call the function with a couple of examples and look at the output. I'm just going to put a couple of calls here, and I'm also going to revert to the myDNA string that was declared and used in earlier videos. So there's myDNA, and I'm going to print out what I get back from calling the function is AT-rich. I'm going to send in this long string myDNA. That's the actual parameter which contains that string, and the formal parameter of the function is going to take on that value and process it. And then I'm going to call it again down here with a shorter string, and one of these is rich, one isn't, so we'll see the different results. So let's run the program and look at the output that we get. So if I haven't made any copying and pasting mistakes, I didn't, and here's the result. Right? So in the first case, the DNA is true, it's rich, so it's greater than 0.65. And in the second case, this other call here, it was not, so it printed out false. So then you can write functions that return Boolean or true-false values. Now, as it turns out, we can make this a simpler function by doing the following small change. So let's move this out of the way. And instead of using this if statement at the end, then we can make it much simpler by just putting in the single line here. So if I put this in, and I can take out the if statement altogether. So this is going to return AT content greater than 65. All right? So that single statement replaces this if statement up here, and it does the same thing. So I'm going to delete the if statement, and I'm just going to have the return here, return AT content greater than 65. So note, this is a relational expression, and it's going to end up being either true or false. So that will shorten our function, and we don't actually have to have that if statement in there. Okay, so now let's run the program once again and look at the output, and here we go. So we'll run it, and I'll bring over the output. And once again, you see we get exactly the same result here. So we get true for the long string of DNA that we send in to begin with, and we get false for the other one because its AT content is going to be less than 65. So there you have it. Though there's another program which is going to go through these logical expressions or logical operators. You can use and, you can use or, and you can use not. So those are things now that give you a great deal of power in putting together an expression that tests for something. So you can combine those relational expressions with and, or, and not, and you can do quite a substantial test with those. That gives you greater capability and power in your Python programming capabilities. Now, I think that's sufficient for this example, so let's stop the video here.